So now what we're going to do is demonstration number 6, and what we're going to try and do is a running bump test to determine if we have resonance with this piece of equipment. Resonance, very common problem in industry. You don't want to run your machine at the resonant frequency, which is the natural frequency of the machine. And so let's say you're out in the field, you collect some route vibration, and you see some alarms on the screen like I've got here. I've got high 1 times, high 2 times. Well, is that looseness? Is that resonance? Well, we could go and do a running bump test with negative averaging to determine if we've got resonance on this machine. So what I'm going to do is come over and press F12, Run Analyze, and I come into the Analyze application, and I'm going to press F7, More Experts, and then F3 is Bump Test Equipment Running. And so once I get into there, what you'll see are these steps for performing this test. And that's the nice thing about these analysis experts in the CSI 2140 is that there's instructions on how to perform the test. You may not perform these every day. You might have forgot how you performed it last time. So it's a nice reminder to be able to see how you can perform this test. And it's saying, look, you're going to impact this machine once per average and record the vibration levels. And then for the second step, you're going to stop impacting the machine and record the vibration levels. And what it will do is subtract the running vibration of the machine, and what you're left with is the impact, and that's the negative averaging. And so that impact should excite the natural frequency of the machine and show up as the resonant frequency. Now what I'm going to do is press F1 and adjust my setup here. My Fmax is 2000 Hertz. My lines are 6400, so I'm going to press F2. I'm going to lower my number of lines here. I don't need that much resolution. I'm going to take it up to 800. Press Enter. And I've got 12 averages. I don't really need that many averages either because I don't want to hit the machine that many times for this demo. I'm going to take it down to 6 averages. It's negative average mode. Okay. And I'm going to hit Enter. And then I'm going to come over and I'm going to set a trigger by pressing F9, Set Trigger, and I'm going to arrow down to Level Trigger. And I'm going to put the trigger level, F10, at 1G. And press Enter, and press Enter. And now I'm ready to run the test. And remember what I said, we've got 6 averages, so I'm going to impact the machine once per average while the machine is running. Now the nice thing about this bump test while it's running is you don't have to shut the equipment down. The equipment's always running, it's in service, you're making whatever the plant's making, and you can still get a nice bump test while the equipment's running. So I'm going to press Enter. It says waiting for the trigger. It got the trigger. Second average. Third average, fourth average, fifth, sixth. Now F3 says negative average. And so now what it's doing is it's recording the vibration just with the running of the machine, and it leaves me with the energy from the impact that I did. So I can press Stop, F3. Expand the x-axis, and so now this large peak that you see here, it should be the resonant frequency as a result of the impacting that we just did. And so that is about 20 Hertz. This machine, the running speed is 1700 and something, so it's up around 30 Hertz. So we're good, we're not running this machine at the resonant frequency of 20 Hertz. So what this test told us was that the energy that we were seeing at the 1 times and 2 times was not associated with a resonance condition because we've identified the resonant frequency was at 20 Hertz. We know our running speed's at 30, so we're not exciting that resonant condition. So we've eliminated that as one of our problems with the machinery health.